Hey, I am Mr. Crocker, and we are going to be talking more today about number lines and fractions. And the reason we're doing this is because on your state test at the end of the year, there are usually quite a few questions where they ask you to find a number on a number line or choose which circle best represents a certain fraction on a number line. And so I want us to get pretty familiar and comfortable with number lines ahead of time, okay? Because they can be pretty confusing if you haven't had any practice with them. So today we're going to do some more partitioning of number lines, okay? We're going to do that to show the value of fractions, the value of a fraction in relation to 0 or 1, but also equivalent fractions. So I've got three number lines here, same start and stop. They're all, let's just imagine that they go from 0 to 1, okay? So we're just doing the fractions between 0 and 1. We're going to start with halves. So half means two pieces, right? Two even pieces. That's pretty easy, right? We would just put that in the middle. And the fractions that go along with that would be 0 halves, 1 half, and 2 halves. Okay, so anything with 0 as a numerator means 0, right? It doesn't matter how many pieces you cut something up into. If you don't have any of them, you have nothing. Okay, and then you're counting up until the top is the same as the bottom. When the numerator and the denominator are the same number, then that means it's a whole, even if it's 3/3 or 4/4 or 12/12. Same on top and bottom means one whole. Okay, so there's 1 half. 0 halves, 1 half, 2 halves. Now, fourths. So let's go into 4 pieces. And the last time we did this, we talked about going not just from like start to finish, but cutting in half and doubling. So, 2 doubles to 4. So I'm going to start with that half, right? And now if I want to get to 4, I just cut 2 more pieces. And so now I have 1, 2, 3, 4 pieces. And the fractions that go along with that are 0/4, 1/4, 2/4, 3/4, and 4/4. Okay, and so one of the things that I want you to be gaining from this little exercise that we're doing here is if you were asked to point to 3/4 on a number line, you would know that it should be somewhere past half. If you were asked to point to 2/4 on a number line, I would hope that you would know, well, that 2/4, that sounds like it's in the middle, right? Even though it doesn't say a half, we can see here that they line up. Those are equivalent fractions. Okay, let's move on to eighths. So if I double 4 again, I double it up to 8. Okay, so I'm just gonna 2 pieces, right? 1, 2 pieces. Now I've got 4 pieces. And now I've got 8 pieces, just by half, half, half. Okay, so I can count them to be sure. 1, 2, 3, 4, 5, 6, 7, 8 pieces. Okay, so starting with 0/8, 1/8, 2/8, 3/8, 4/8. That's the middle. 5/8, 6/8, 7/8, and the one whole unit is 8/8. Okay, so there we go. We did 3 number lines, halves, quarters, and eighths. Now let's talk about some equivalent fractions. So first, if we just look straight down the middle of all of our number lines, we've got 3 equivalent fractions. Okay, 1 half, which is equal to 2/4, which is equal to 4/8. Okay, and we can multiply there to make sure that that's true. 1 times 2 is 2. See, multiplying top and bottom by the same thing got us from 1 half to 2/4. And if I multiply again by 2, top and bottom, 2 times 2 is 4. 4 times 2 is 8. So those are equivalent fractions, okay? Now, we have more equivalent fractions than just the halves. So 1/4, if we look, it lines right up with 2/8. And we can put that down here, 1/4 and 2/8. Those are equivalent fractions. And again, I can test that with multiplication. Okay, 1 times 2 is 2, 4 times 2 is 8. That worked out. Okay. 3/4 lines up with 6/8. 3/4, 6/8. Equivalent fractions. Times 2 times 2. It's not always times 2. It just is on this number line, okay? And then, of course, the 1/2 and the 0 fractions are all equal also, okay? So trying to figure out where you can see it best, where to write here. So 2/2 is equal to 4/4 is equal to 8/8. These all mean 1/2. And same with 0/2 is equal to 0/4 is equal to 0/8. Those are all equal. All the ways to write 1, all the ways to write 0. Okay? So those were the two number lines, 2, 4, and 8, right? So now let's look at the fractions we can get to through 3. So we'll start with thirds, and thirds are a little bit tricky because they don't have a middle, right? You can't find middle. It's got to be 3. So thirds. Okay, I have 3 pieces. 0/3, 1/3, 2/3, 3/3. Okay, that's how that works. Sixths is the next number line, and I can get to sixths if I just take thirds. See, I kind of just carried those lines down. Now I'm just going to cut each one of those in half. And I went from having 3 pieces to having 6 pieces. So now they're sixths. 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. Okay, and we have some equivalency here, right? Those lines that I carried down. Okay, 2/3 is equal to 4/6. Doesn't that make sense? Because it takes 2/6 to make a third, right? It takes 2 of these little slices to make a bigger slice. So 2 of these would be 4 of those. Same thing here. 2/3. Oh, I did that one. 1/3 is equal to 2/6. 1 big piece is 2 little pieces. 2 big pieces is 4 little pieces. Okay. Okay. Ninths. I can carry that line down again because 9 is a multiple of 3. Okay. And now I'm not just doubling. From 3 to 9 is not doubling. It's 3 times more. 3 times 3 is 9, right? So I need to break each third into 3 pieces. Okay. And that should give me 9. So 0/9, 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9, 9/9. And again, another reason that we're doing this is because if you have to find the fraction 5/9 on a number line, I want you to know, well, 5 is going to be kind of close to the middle, right? Or 1/9. Well, 1/9 is going to be pretty close to the beginning. And I feel like this will help you get there. So if we look at those lines that we carried down, 2/6 is equal to 4/6, which is also equal to 3/9. Okay. 2/3, 4/6, 6/9. I did that backwards. We gotta have a mistake in every video. 2/3, 4/6, 6/9, 1/3, 2/6, 3/9. That looks a lot better. Okay. Okay, so we did ninths. Now let's do twelfths. Okay, so I can get there through 3. There's 3. Okay, 3 times 4 is 12, right? So if I put 4 little pieces in each one of these, I'm going to end up with 12. So look, I can do half. That's 1, 2, 3, 4 little pieces. Bang, bang, bang. That's 4 little pieces. Bang, bang, bang. That's 4 little pieces. I should have twelfths. Okay, so 0 twelfths, 1 twelfth, 2 twelfths, 3 twelfths, 4 twelfths, 5 twelfths, 6 twelfths, that's exactly the middle. 7 twelfths, 8 twelfths, 9 twelfths, 10 twelfths, 11 twelfths, and finally 12 twelfths is a whole. Okay, so what are our equivalent fractions? I can eyeball it, and I can tell you that 2/3, putting it with the right one this time, goes along with 8 twelfths. I can tell you that 3/9, that's over here, goes with 4 twelfths. So doesn't that kind of make there are a lot of patterns in equivalent fractions. Okay, 2, 4, 6, 8, 3, 6, 9, 12. Yeah, that's kind of going along. You know, like let's look at these two. 6/9 and 8 twelfths. So this is kind of a funny example of equivalent fractions because there's nothing I can multiply 6 by to make 8, right? And that's what we have learned, is that you multiply top and bottom by the same thing to make equivalent fractions. And it usually is good, but here, there's nothing I can multiply by to get from here to there. But what I can do is cross multiply. Remember that? So 6 times 9, not 6 times 9, 8 times 9, that's 72. 6 times 12, also 72. So I can check that way, and the cross products show me that those fractions are equal. Okay? 2/3 and 6/9. I said that wrong. 2/6 and 3/9. Okay? 2/6 and 3/9. Okay, there's nothing I can multiply 2 by to get 3. So this is another funny example of equivalent fractions, but I can do my cross products, and that's 18, and that's also 18. So I know that these fractions are equal. Okay? Fractions on a number line. Got to stretch and